Okay, welcome back. So I know that was a lot of reading and a lot of information that you got. So what I wanted to do here is kind of pull it a bit all together a little bit and make you feel better that this is actually worth your time. So what I've written here is an example, and this is written in Einstein summation notation, a sub I j x sub j. This is based off of the matrix that you actually saw earlier, which is the matrix A. And it's based off of the vector that you saw earlier. I just used j as the index. So a sub I j x sub j. The question is, first of all, this actually represents some sort of matrix or vector operation, and I can 100% guarantee that you do know what it is. But it's just sort of obscured by this notation. And what I really want to do is really show you what this means. So really, if I were to write this in just sigma notation, what this would look like is it would look like the summation from j equals 1 to 3. I'm going to still stay in this three-dimensional space here of a, I, j, x, j. Now notice that I chose j as the index for the summation. And I did this on purpose. Why? Because it's repeated. And if you were thinking earlier that maybe one of the rules might have something to do with the fact that j shows up twice, you should give yourself a gold star, because that's 100% right. So one of the big major rule of Einstein's summation notation, and this is the overarching rule here, is that if an index is repeated, in a product. Now notice we only have one term here, but if we had multiple terms, this would apply to every term individually. So if an index is repeated in a product, then summation is implied over the repeated index. So this is actually the most important rule. So summation is implied if the index is repeated. Okay, this is Einstein's summation notation. So we all agree that if we remove the sigma notation and an index is repeated, then we assume that we're supposed to sum over that index. Okay, so now there are some additional rules that are important to understand. So really these rules are just so we don't write an equation that makes no sense. So here are a few of the additional rules. So this is number 1 in your notes, that the same index or the same subscript, if you will, may not appear more than twice. Okay, and again, if there were multiple terms, this would apply to each term individually, which is a little bit disconcerting when you look at each individual term. Well, the j in the first term is different than the j in the second term. So just understand that each product, each term is different in term. They're independent. The indices in each term is independent. So just keep that in mind. So let's look at a couple of the examples that I gave you in the notes. So a sub I k x k. Well, have we violated any rules here? It does not appear so. We have a repeated index, which is k, and it only appears twice. So this is perfectly valid, so we'll give it a green check mark. All right, what about this other one that I gave you? A sub k k x k. Well, this is obviously very bad. The k's appear 3 times, and this actually just doesn't make any sense. So this breaks rule number 1. We don't want to write this. All right, rule number 2. So rule number 2 is really just definitions. So what we're going to do is sort of define the definitions. So the dummy index, and I didn't name this. So the dummy index is the repeated index, and that's all you need to know. It's just the repeated index and the free index is the non-repeated index. Or there could be more than one. Okay, so let's just go ahead and call out. So I think I gave you a couple of examples. C sub I equals SIK XK. So if we look at this, it looks like K, I'm gonna write this in blue. So K is the dummy index because it's repeated, and I is the free index because it's not repeated. And this is perfectly valid. So we'll give this a green check mark because this is fine. All right, and I gave you a bad one, I'm pretty sure. Oh, I didn't give you a bad one. I'm sure that you can figure this out. So let's just go ahead and look up at some of the other problems here. So in number 1, K and I are so this is the free index. K is the dummy index, and I is the free index. Okay. All right. Moving on to rule number 3. So rule number 3 just says that the free index has to agree on either side for basically for every single term. So I gave you a good one. So free index, or I'll do free indices again. There could be more than one. On each term, remember that each term must agree. And really what this means is that the dimensions agree, if you want to think of it that way. So for example, x sub I equals u sub I plus c sub I. Okay, this is perfectly valid because every single term has a free index in it, and the dimensions agree basically. Now here's a not so good one. X sub j equals a I k u k. So notice we're summing over the k's. So we really needed either an I on the left-hand side of the equation, or that I on the right hand needs to be a j. So this is nonsensical. You don't want to write something like this because it doesn't make any sense. Okay. And finally, the last rule, which is a bit disconcerting, I freely admit, is that free and dummy indices may be changed without altering the meaning of the expression. So what does that really mean? Well, if I have x, so I'm actually going to use a different example than I gave you in your notes because that will give you more ways for you to see what I'm talking about. So if I were to look at this valid equation in number 3, x sub I equals u sub I plus c sub I. Well, if I just decide I really hate the index I and I really want, I don't know, p, I could just replace every I with a p. X sub p equals u sub p plus c sub p if I wanted to. As long as if I goes from 1 to 3, p would have to go from 1 to 3. So as long as I preserve the range, it doesn't really matter what the index letter is. Okay, so let me go ahead and use another example. Let's just start with the very first one, a sub I j x j. Well, if I actually really dislike all of these letters and I want them to be different, I want m and n. Well, let's say I want it to be a sub m n. That means x would have to be n, or j would have to be n. And as long as I preserve the range on these indices, then I'm allowed to interchange them. It doesn't matter. Okay, so you have to be consistent. And I believe this is a little bit disconcerting because in mathematics, there should only be one answer, but that's not really true anymore. There is a little bit of freedom of choice here. But these are the rules. So what I'd ask you to do is go through these rules again, read through them one more time. And then what I've provided for you in part C is I provided for you some things to think about. The solutions are at the bottom of the note taker, but what I ask you to do is I just ask you to think about it for a while, and I guarantee you know what all of these vector or matrix operation equivalent expressions are. I can guarantee it. Okay, so good luck.